Hi there, folks. Today we're looking at solving compound inequalities. Remember, compound inequalities are just two inequalities that are being graphed at the same time, that we're using at the same time. And so if it's just two inequalities, then it's just solving two inequalities, and that's all this is. So solving compound inequalities, we just solve each inequality individually, all right? It's like we have two problems to solve in each of these problems, all right? So we solve the inequality, and remember, solving inequalities is just like solving equations. We work backwards through order of operations. We undo the operations as we go. The big difference with inequalities is if we multiply or divide by a negative, we have to flip the inequality symbol, okay? So we're just going to solve each of these inequalities individually, and then we'll have the word and or the word or in between. And remember, and has that special format, which we'll talk about in a little bit. So if I look at this first one, I have two inequalities. I've got 1/2 x minus 3 is less than or equal to 7. I also have 2x is greater than 8. I'm just going to solve each of these individually. I'm going to ignore this second one here. Let me scribble it out for a second. Ignore that guy. Let's just solve this first inequality. I undo the subtraction first, so I'm going to add 3 to each side. So I get 1/2 x is less than or equal to 10. And now remember, a 1/2 is the same as a divided by 2. Remember, a fraction bar is a division sign. So to undo dividing by 2, I'm going to multiply each side by 2. I didn't multiply or divide by a negative, so the inequality symbol stays the way it is. And there it is. That one is solved. I just have to go back up and say, wait a minute, I had 2 of these. Time out. Here, let me scribble this guy out that I just did. Let's solve this inequality. I've got 2x is greater than 8. To undo multiplication, I use division, so I divide each side by 2. So I end up with x is, actually, let me write it a little bit lower, because that one was only one step. X is greater than 4. And so the only difference between this and solving two just random inequalities is I had the word and in between. I'm going to put that word and in between again. Okay? For added practice, we could graph this thing. And again, if we start to think about this, I want to be less than or equal to 20, but I want to be greater than the 4. So when I do the graph of this guy, again, down here is the 4. Maybe I'll go by 4, so 8, 12, 16, 20, because I knew they weren't all going to fit. Okay? If I thought about each of these individually, remember, I'm going to float it out in space here. Less than or equal to the 20. Greater than the 4. And so again, with an and, I only want the stuff they have in common. Well, the stuff they have in common is the stuff that goes from 4 to the 20. And I shade everything in between. Okay? And so when we look at this thing, the answer is this and inequality that's up here. And remember, I could also write it like this. When I look at the graph, and the graph is a great way to kind of figure out how to write it in this other format, you could say that, hey, we're between 4 and 20. Notice I'm mimicking the graph. X is in between those two values, less than symbols. This guy gets an equal to because of the closed dot. Okay? Either one of these would be an acceptable answer for this guy. It's easier just to leave it with the word and in between. But if you're feeling bold and you're really excited about writing this in as one thing, try write the other way. All right, it's something that is nice. It's nicer to look at that way. Okay, so if you want to try writing it that way, go for it. Okay. If I look at the next one, an or inequality, it's just two inequalities. I'm just going to solve each of these. And again, I'll ignore this guy for a second and say, okay, how do I solve this guy? Well, to undo addition, I do subtraction. So I'm going to subtract 2 from each side. I didn't multiply or divide by a negative, so the inequality symbol stays the way it is. And now I say, okay, let's forget the fact that I was ignoring something over here. Let me ignore the first part now. Oh, how do I solve this one? I divide each side by 5. Again, I didn't multiply or divide by a negative, so the inequality sign stays the same. And then the only difference is, there was the word or in between, so I better write that or in between. And now I could graph this thing. Let's draw a quick sketch of the graph. Whew, just fit it on there. Let's see, I've got less than or equal to, so closed dot and shaded this way. Remember, I graphed the two pieces. Greater than or equal to is a open dot, and I shade this way. Okay, I'm just graphing the two pieces individually because I'm giving myself options. Remember, and is one thing together, or is two things separately. It's this thing or this thing. It's showing us our options. Okay. Again, the solution is just this guy. The graph is just there for good measure. Okay. If I look at something like this guy, remember this is an and inequality, and it's kind of written in that special that special way. When you look at this thing, it's just two inequalities. If I were to kind of just scribble this guy out, let's write that inequality, but let's write it in the way that it should be written, right? I should write the 3x minus 1 first. And then think about that. I've also got the negative 4. Think about which way that inequality symbol should face. Well, the alligator was eating the 3x minus 1. Make sure it's still eating the 3x minus 1. And now I can put the word and down. And now this guy, this one's a little bit easier to see. I scribble that out. Let's write it down. 3x minus 1 is less than or equal to 5. Remember, when it's written in that form, it's just two inequalities, just written in a special way. Okay? And now I can solve each of these. This first one, I'm going to add the 1 to each side. I'm going to divide each side by the 3. Once again, I'm dividing by a positive 3, so this stays the same. Over here, I'm going to add the 1 to each side. And then divide by the 3. So I'm solving the same way I've always solved. So now I've got less than or equal to 2. Okay? That's one of the options for solving this thing. But I want you to pay special attention to the fact that I just did the same steps for each of these equations. Let's look at the steps. So in this first inequality right here, this guy, I added 1 to each side and then divided each side by 3. If I look at how I solved this inequality, I added 1 to each side and then divided each side by 3. Okay? And so notice I did the same steps. Here's the other way that you can solve this. So let me slap the word and in between. Okay? That would be one of my answers. I could write it as, x is greater than negative 1 and x is less than or equal to 2. Here's the other option. Let me erase this. I'm going to start over. Since I'm doing the same steps to solve each of these, what I can do is I can leave it in this format, and I just have to look at the middle. I look at the middle where x is and say, okay, I want to solve for x, and right now, the x has a minus 1 and a times 3 that I need to get rid of. So to do that, I use those steps of adding 1 and dividing by 3. But instead of doing it to 2 pieces, I'm going to do it to all 3 of these pieces. Watch this. I look at the middle and say I want to add 1. Well, I have to do it to the left side and the right side. Okay? And again, it's that idea of, hey, let's start in the middle where x is. I look at the middle where x is, and I undo. And now watch this. Negative 3, 3x, 6. And now I look at the middle again. I say in the middle, if I want to get x by itself, I have to undo times 3, so I have to divide by 3. But now instead of doing that to 2 things, I'm going to do it to all 3. So I do it to the left, and I do it to the right. And so over here, I get the negative 1. In here, I have the x. Over here, I have the 2. I didn't divide by a negative, so I leave the inequalities, the symbols the same. And these are my 2 versions of the answer. Okay? When I look at this thing, these are the same thing. See, if I look at this guy, if I were to rewrite this with x first, it's this. And then if I were to look at the second half of this thing, it's this. Okay? Remember, we can have an and inequality written in this special format. And if it starts in that special format, we can just solve it that way. It stays in that nice, neat format, and it actually saves us a little bit of work, okay? We just have to remember where to look in order to figure out what operations we need to undo. We look at the middle where x is, and we say, how do I solve for x? How do I solve this middle for x? And I do the same thing to the left and the right, okay? If I look at the next one, just 2 inequalities. Oh, sorry, I didn't graph the previous one. Let me draw a graph. I'll draw the graph in between here. And see, again, the thing I really like about that top version is it's much easier to graph. I say, hey, the x is literally in between a -1 and a +2. So -1 gets the open dot, so you know equal to condition. Right here, 2 gets the closed dot because there is an equal to condition. And x is in between those. I shade in between. Okay? And I'll get the same thing if I graph the inequalities individually and say, hey, where do they overlap? What do they share? All right? But when it's in this special format, graphing is easier because it's showing me that x is in between these two values, so I shade in between. If I look at this guy, again, I'm going to solve each of these individually. To solve the first one, I need to add 4 to each side. So I get x is greater than or equal to 10. The second one, I just solve it. I say, okay, -2x is greater than 8. To undo multiplying by -2, I have to divide by -2. And be careful here. This is where that special rule comes in. I just divided by a negative, so I have to flip the inequality sign. Okay, so it becomes less than a -4. And don't forget to slap that or back in between. So it's an or inequality. Now it's solved, and now I can graph the thing. Let's go by 2's here. Oh, I'm going to have to extend the graph. I was close. I didn't quite make it. You know, you got to anticipate this stuff, Mr. Jansen. You got to be better. Okay? And so now if I graph each of these, and again, we just graph them. I show my two options, so I just draw each of the two pieces. Open dot less than. Close dot greater than. See, I have the two pieces. That's what an or inequality looks like. And so this is the answer. The graph is just me showing that answer, okay? If I look at this one, let's see if we can do it by keeping it together. So again, you could split this up, all right? You could split this up. If you did split it up, one of them would be the -2x plus 3 is greater than or equal to the -3, okay? And then the other one, you'd have the and, would be the -2x plus 3 is less than 5. And again, you got to be really careful when you split it up, especially this first piece, because you have to rewrite it the way we've been rewriting these, okay? So you put the -2x plus 3 first, but then make sure the alligator's still eating the -2x plus 3, okay? Here's how we do it. If we kind of looked at each of those individually, like if I looked at this guy right here, I would solve this by subtracting 3 from each side, and then I would divide by the -2. This one, I would solve by subtracting 3 from each side and then dividing by the -2. And so when we look at it in this format where it's all together, I look at the middle. If I look at just the middle and say, okay, if I had that and I want to solve for x, I have to subtract 3 from each side to get x by itself and then divide by -2. And so I start with the middle and say, hey, subtract 3. Whatever I do to the middle, I have to do to the left and the right. And so here I get -6. The signs stay the same. And now I look at the middle again, and in the middle I have to divide by a -2. So I do the same thing to the left and the right. And what happens here, I divided by a negative, so I have to flip these inequality signs. So this becomes a greater than or equal to. This one becomes a greater than. And so this is kind of okay, all right? And that would be an acceptable answer. But it isn't written the way I really like it. I should start with the -1, then the x, then the 3, from least to greatest. And now think about that. Make sure the alligators are eating the same thing. So this guy, between the x and the 3, the alligator was eating the 3. This guy, between the x and the -1, the alligator was eating the x. And see, now it's written in that nice format when I go to graph it. I can slap these values down. I say, hey, no equal to condition here, equal to condition here. The x is literally in between those two values, so I shade everything in between. And again, you can do that using this first version of this thing. I'm trying to erase the... Oh, my fingers are having a little trouble. There we go. You can do the same thing using this first version. It just looks a little weird because the -1 and the 3 are kind of out of place. But either one of these would be an acceptable answer. Okay. The second one makes a little bit more sense, and we can see it on the graph a little easier. Okay. And then this last one, here we go. To solve that first inequality, I subtract 6 from each side. And now I divide by 2. Again, I didn't multiply or divide by a negative, so I leave the inequality symbol alone. The next one, this one might be a little bit tricky, but remember, when we see a bunch of fractions, just a bunch of division, I can get rid of a bunch of division by multiplying, okay? And the thing I multiply by is the common denominator. So when I look at this, all of the denominators are 4, so the common denominator is also 4. So let's get rid of everything all at once. Let's multiply each side by 4. And so now I use my distributive property. If I distribute this 4 to each of these, 4 times 1/4, again, remember, 1/4 is just divided by 4. So 4 divided by 4 is 1. If I look at 3/4, remember, that's just times 3 divided by 4. So 4 divided by 4 is 1, times 3 is a 3. Or you could say 4 times 3 is 12, divided by 4 is a 3. Okay? But again, it's just multiplication and division canceling each other out. And now let's finish solving this thing. I'm going to subtract the 3 from each side. So x is greater than 5. Don't forget to put that little or back in between. And then we could draw a quick sketch of the graph. Let's graph it. And so the first one, I just graph each piece. Remember, or is 2 options, so I graph 2 separate pieces. So less than this guy, open dot shaded to this side. Greater than this guy is an open dot and shaded to this side. Okay? So again, this is my answer. The graph just gives me a visual representation of that answer. Okay?